All right, so for the bell work, we need to simplify this expression. You can do it in a million different ways. The easiest way is to resolve the top and then the bottom, and then deal with this -2 later. So for right now, we're going to just simplify the top. I've got 5 to the -2 and 5 to the -3. Those two combine together to make 5 to the -1 on the top. On the bottom, if I take care of the stuff inside the parentheses first, that ends up being 5 to the 2, because 4 minus 2 is 2. So from here, I have this -3 to times by to +2, and I end up with 5 to the -6. I just simplified the top and the bottom individually. So now if I want to, I could take this -2 and distribute it to top and to bottom, and I'd get 5 to the 2 over 5 to the 6. Nope, sorry, 12. If I take 5 to the 2 minus 12, I end up with 5 to the -10. I can't have negative exponents, so that means it goes on bottom. So I have 1 over 5 to the 10. Is that what everyone else got? Yeah. All right, so that's kind of an example on how to do it when it's just numbers. If we involve some variables in this problem, we're going to have to take care of this multiplication. When you multiply fractions, you just multiply straight across, right? Top and bottom. So this ends up being 8m to the 3rd, and on bottom it ends up being 36m. So 8 over 36 reduces down by at least 2. That ends up being 4 over 18. That can reduce again by 2. Ends up being 2 over 9. So just the numbers alone, I end up with 2/9. And now if I look at the variables, I have m to the 3rd minus 1. We're doing a subtraction principle with division. This ends up being m squared, and since it's positive, it goes on the top. So my final answer should be 2m squared over 9. Right? I multiply the two fractions, and I simplify the result. Any questions about this one? Okay. So for the next example, say again? It did a little bit. It's a little bit finicky. So we have a multiplication problem. I times the top and the bottom. I end up with 27x cubed over 12. Can any of that be reduced? Yes. Looks like a 3. A 3 goes into both of them. So divide the top and bottom by 3. And I end up with 9 over 4. The x cubed stays on top, and we're done. Everything's okay with that? All right. So next example. We end up again with a multiplication problem, so we times the top and the bottom. 24n over 27n to the 4th. I've got 4 n's on bottom and 1 on top. We can reduce this down to be just 3 on bottom. So I have n cubed, not m, n cubed on bottom. And the top, the numbers can reduce. 24 and 27 reduced by 3? At the very least 3. So we end up with 3 goes into 24 8 times, and 3 goes into 27 9 times. So I have 8 over 9n cubed. Question? N cubed. If I just look at the variables, I have n over n to the 4th. This is n on top, n, 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 n. There's 4 n's on bottom, right? If I cross off the n's, I end up with 3 on bottom. Agreed. You're going to say that you want to do the subtraction principle. N to the 1 minus 4 equals n to the -3. But since it's negative, it goes on bottom, right? So that's where the n cubed on bottom comes from. Same principle, same concept. Just one's using the formula and one's using logic. Okay? Great question. Any other question about this example? Okay. Last example before the homework. Again, we're doing a multiplication of fractions. I times the top and I times the bottom. 5 times 18 is the same thing as 10 times 9, which is 90. N to the 7th. Question?
Okay. Would you be able to reduce that before so you don't get those big numbers?
Absolutely. If you want to, we can reduce first. 5 and 15 reduces to be 1 over 3n cubed. This would reduce down to be 9n to the 7th over n to the 4th. If you wanted to, we could reduce even further, right? Because this n to the 4th and n to the 7th would end up being 1 over 3n cubed. That's a weird looking n. 3n cubed for this one. But these n to the 7th minus 4, right? N to the 7 minus 4 is 3. Do you understand that concept? We're good? So it gets 9n to the 3rd over 1. You okay with that? Did I lose you? Be honest. So now the multiply across. I get 9n cubed over 3n cubed. The n cubes go away, and I'm left with 9 divided by 3 is 3. So the final answer should be 3. Huh? Let's see. If I didn't reduce. Some people are saying, well, what if you didn't? What if you just did it the exact same way you've been doing it all along? Times by across. This is going to be 90n to the 7th. It's not 9, sorry, 90. What am I doing? My brain is so broken. 90n to the 7th. There we go. On bottom, 15 times 2 is 30. N to the 7th. Do you see that? N to the 7th and n to the 7th go away. The zeros go away. 9 divided by 3 is 3. So simplifying first is easier in some instances, but that one, it seemed easier just to multiply it straight across before you simplify. So go ahead and work on problems 1 through 10 on the worksheet. We'll give you about 5 minutes or so. Describe the negative exponent property in your own words. Oh, geez. Describe the negative exponent property in your own words. I'm going to go ahead and say if it's negative, what? What happens if it's negative? Kind of switches top or bottom, right? I'll just say switch top or bottom. So if it's on the top and it's negative, it moves to the bottom. If it's negative on bottom, it switches to the top. So that's a good way to write that. So now we're going to deal with division. Division of fractions. Instead of writing it as division of fractions, let's go ahead and write it as a multiplication of the reciprocal. When you divide fractions, you flip it and multiply, correct? So we're going to flip it. 7x over 12 times 6x over 4x cubed. This is how division of fractions work. Okay. Now we multiply just like last time, times across the top. I get 42x squared over 4 times 12 would be 36x cubed. Now we can simplify. We can reduce it down a little bit. X squared over x cubed. That reduces down to be x to the 2 minus 3 is x to the negative 1. Since it's negative, it goes on the bottom. Yes?
Isn't it 48?
No.
7 times 6 is 42.
48. 4 times 4.
Oh, it's a 4. I read a 3. I don't know what happened there. That's crazy. All right, you're right. 48. Thanks. I don't know why I saw 12 times 3. My brain was broken. So it's a negative, so it goes on bottom. I know I have an x on the bottom. If I reduce the fractions, what goes into 42 and 48? 6. Sure, let's do 6. If I divide the top and bottom by 6, I end up with 42 divided by, that's a 7. And then 48 divided by 6 is an 8. So we have 7 on top and 8 on bottom. Are there any questions about how we got that? It's the same thing as above, but we have one more step. We have to flip that last one. If we're doing division of fractions, you have to flip the last set of numbers. So these two have to be flipped over. So let's go on to the next one and see what we can get. Say again?
KFC. Is this like a method for this? Like you keep the first sign and you flip the division thing and you change the fraction?
No, not KFC. This is just flip the last one. You don't change the sign.
No, I learned it in 7th grade.
No. It does apply to certain situations,
Okay.
but it's not for this one. That's for perpendicular or parallel, I believe.
Oh, okay.
Okay? So for here, all we have to do is flip over the last fraction. I end up with 2 over 6w doesn't change. We times it by 4 over 9w cubed. Multiply the top and I get 8. Multiply the bottom and you get 6 times 9 is 54. W to the 4th. So flip the back one and multiply across the top and bottom. Now we can reduce. Does anything go into 54 that goes into 8? At least a 2. They're both even, so at least 2. This ends up being 4 over 27. And then the w cubed, the w to the 4th power stays on the bottom, so there's your final answer. Okay, flip it and multiply. That's the only change to this new set of problems. So we'll get another couple minutes to work on homework. You want me to leave on the examples? Okay, I'll leave both the examples up during the pause to work on homework. So 5 or 6 minutes, work on homework. So for the last set, we got to realize that it's just going to be the same concept, just intermixed. So notice here we have multiply, divide, divide, multiply. They're interspersed throughout the events. So you got to know and recognize what to do for each piece. So each question is going to be unique. You can't just say, oh, for this one I flip it and multiply. It depends on what you're doing. So right here, let's go ahead and say, since it's multiply, we just multiply the top and the bottom. 14 times 4 should get me, that's 7 times 8. 7 times 8 is 56. Sure, we'll say 56. Z to the 4th. 12 times 7 is 70, 80, 84. And then z to the negative 3 times z, ooh, that's a good one. Z to the negative 3 times z to the 1. I add those together. Negative 3 plus 1 is negative 2. So this should be z to the negative 2. All right. So I just took care of the multiplication process. Now all we have to do is simplify. So I'll notice that 7 goes into both of those. So if I divide the top and bottom by 7, now you may not see that 7 goes into both of them, but you can try other things. Go by 2s or something. So if I divide both by 7, this should be 8 on top, and it should be a 12 on bottom. Now that can simplify further, but let's look at the variables for a second. Z to the 4th minus negative 2. So the negative and a negative combine to make it positive, so that gets me z to the 6th. Since it's positive, it goes on top. So I have z to the 6th. Now 8 and 12 reduce down by 4 to get 2/3. So my final answer should be 2 z to the 6th over 3, I believe. Anybody want to check me out with a calculator? See if I did it wrong or right, whatever works. I have no idea. So, any questions on that example? Okay, let's get into multiple variables. If you'll notice here, it's a divide problem, so we have to flip it and multiply. We know that part. But also notice I have a v and I have some y's involved. You can't combine those together because they're different letters. So we just have to treat them differently. So if I flip this over, I'm going to end up with 42 y to the 4th over 28 y cubed times 6v to the 4th over 21 y cubed. Okay, now for this one, I am going to recommend we simplify it. 42s, and those are big, big, big numbers. I prefer not to deal with big numbers. So if I simplify the first one, 42 over 28, what goes into both of those? 7. Nice. So if I divide the top by 7 and the bottom by 7, I'm going to end up with 6y to the 4th over 4y cubed. So that got rid of my big numbers, right? And 6 and 21 both are divisible by 3. So this is going to get me times 2v to the 4th over 7y cubed. So now I could simplify further now. Any questions? I'm getting some confused looks. You could, absolutely. If you want to simplify this again, you could do this as 3y to the 4th over 2y cubed times 2v to the 4th over 7y cubed. That's a completely legitimate move. If you wanted to take care of some of the variables right now, you could. There's a lot we can do with this. I'm going to go ahead and multiply straight across. I get 6y to the 4th, v to the 4th over 14y to the 6th. Okay. Here we can simplify 6 and 14. Those are both even, so we divide them both by 2. And I end up with 3 over 7. And we have y to the 4th and y to the 6th. So I say y to the 4 minus 6 gets me y to the negative 2. So it goes on the bottom. So I have y squared on bottom. Nothing interacts with the v to the 4, so I just leave it on top, v to the 4. Final answer should be 3 v to the 4th over 7y squared. Any questions, comments, concerns? All right. Next example, again, a division problem. So I can simplify the division. 12ac to the 4th over 5b cubed times, flip it over, 15b to the 4th over 8a cubed c cubed. From here, we could simplify. Are you guys familiar with cross simplification?
Yeah.
So this is 15 and 5. That reduces down to be 3. And this is 12 and 8, which simplifies to be 2 and 3. All right, did I lose you on that one? I'm just checking, see if I lost anybody. If you're okay with cross simplification, then we're golden. 3 times 3 is 9. All that's left over on bottom is 2. So I'm left with a b to the 4th, c to the 4th over a cubed, b cubed, c cubed. Any confusion about what just happened there? I looked at just the 5 and the 15, and that reduced down to be 3. Then I looked at the 8 and the 12, and that reduced down to be 3 halves. So let's simplify the letters now. I have 1a on top and 3a on bottom. If I simplify this, I'm going to end up with just 2a's on bottom. I've got 4 b's on top and 3 on bottom. That means I'm going to have 1 b on top when I'm done with all this. And then I have 4 c's on top and 3 c's on bottom, so I'm going to leave with 1 c on the top. That was just using basic subtraction, some logic. I've got more b's on top than I do on bottom. Can you? No, I did not cross multiply. I cross reduced. That little cross symbol there, that was for saying that the 15 and 5, I reduced those to make 3. See that? And then the 8 and the 12 reduced to be 3 halves. You can cross simplify, yes. Eventually, you're going to multiply them together anyways, right? So if I took 12 times 15, I'd get something, and then I'd have 5 times 8, and I'd have something else. It would reduce the same way. It's just cross simplification before you multiply. Okay, 9bc over 2a squared. Any question about how I did that? Any questions about what we're doing here? 9bc over 2a squared.
What's 9? Oh, 8.
It's a 9.
Good. Let's do it.
Better? Next one. So it's a multiplication, so there's no flipping. I don't change anything over. Let's look at the 18 and the 30. What goes into both of those? At least a 3, maybe a 2. Let's try with 2. That gets me 9 and 15. What goes into 9 and 15? 3. So I end up with 3 and 5. So this number right here is going to reduce down to be 3/5. 25 and 15 reduces to be 5 over 3. So by simplifying the numbers, makes the number smaller. So now I have 3 times 5 is 15, and on bottom 5 times 3 is 15. Well, 15 over 15, that's just a 1, so they actually they all go away. That's kind of cool. So that means I'm left with m to the 4th, that's not to the 4th, sorry, m to the 4th times m to the 3rd, and n times n on the top. On the bottom, I have m, n to the 3rd times n to the 4th. The numbers all reduced. They're all gone. I think. I may have done something wrong.
So it's n to the 4th, n to the 3rd, and n times n.
We can simplify that, right? M to the 4th times m to the 3rd is going to be m to the 7th. N times n is n squared. And then m on bottom by itself, and we have n to the 7th. We can simplify this even further. If I have 7 on top and 1 on bottom, that means I really have 7 minus 1 is 6. So I say I have m to the 6th on top n to the 2 minus 7 is n to the 5th, negative 5, right? N to the negative 5. Since it's negative, it goes on bottom. So I have n to the 5th on bottom. Fully simplified right there. Let me go through and check my numbers, make sure I didn't make a mistake. Because it sure looks like I may have made a mistake. 5, it looks, I don't know, maybe all the numbers did disappear. Oh, phone call. So that finishes up the notes. Make sure you work on problems 21 through 30 and then summarize what you learned today at the bottom of your notes. And that should be all you need. If there's any questions or concerns, please let either Mr. MacArthur, Ms. Kerfman, or Ms. Lowe know. They can all help you. They're all Algebra 2 teachers. Good luck in your classes. And that's it.